Hello, we're doing Chapter 5, Section 2, Properties of Quadratic Functions in Standard Form. I'm doing the guided practice problems, which are very similar to the homework and the worksheet and the problems you're going to be seeing on the assessments. This is on page 328 of the book, which is, if you are looking just at the PDF, it's on page 19. And we're going to do problems 2, 3, and 4. I've had some long videos when I was doing some of these. This one's not going to be long. We're going to identify the axis of symmetry, and notice that all of these, even though that one doesn't look like it, all of these are in vertex form. Vertex form, the function is a times x subtract h squared plus k. All I need to do is figure out what the h is, and the axis of symmetry is going to be x equals h. So, what's my h? It's right here. H equals 2. Because I'm subtracting my h, I'm subtracting 2. H equals 2. So my vertex is x equals 2. You must include the x equals part. Number 3, that does not look like I've got vertex form. That looks like standard form. Guess what? It actually is both. Because in vertex form, this is 3 times x subtract 0 squared. See what I did there? So this x right here is actually x subtract 0. X subtract 0 is still x. So what am I subtracting away to make it look like x minus h? 0. So my axis of symmetry is x equals 0. And this graph right here is actually centered on the y-axis. X equals 0, this is the y-axis, right there in the middle of the graph. And finally, for this one, I don't have an a. Well, excuse me, I do. I don't see it. It's a equals 1. My k equals 0. Neither of those matter. This is x subtract h, which tells me that my h is negative 5, because subtracting negative 5 looks like x plus 5. And my axis of symmetry is x equals negative 5. Now, what I think that you should do, because you want to get a good grade on this, and I'm not going to do it now, I'll do it during live classes, but you should pull out your graphing calculator or Desmos, type each of these in, and then type the axis of symmetry in and see if that's actually the line that looks like this. All right, we'll see you in the next video.